So our first notes are preview chapter A. We take this section here and I split it up into a couple of parts. Your book calls it the preview chapter. It's a little weird. Maybe we call it intro chapter, but they happen to call it preview chapter. They're kind of just going through some real basic stuff in astronomy, just kind of laying the groundwork, because there is part of the class that it's like if you don't have this basic knowledge of things, it's going to make it hard for you to understand other things. Now these are our first notes, so remember, we're writing red text, all red text. Don't paraphrase stuff. Preview chapter, write both things down. This is a heading, so remember when we write headings, big, bold, I can see it, I know that's a heading. If you guys see vocab terms, underline vocab terms. Finally, make sure it's legible. Make sure it's legible. You want to be able to read it, use this as a guide. So preview chapter, here we go. So the cosmic landscape. So here we go. We got another heading. Vocab term, underline, cool. Makes sense. We're starting with the actual term for the class. So astronomy, the study of the heavens and the realm beyond Earth to the most distant reaches of the universe. And we've recently launched into space the James Webb Telescope, which is now allowing us the ability to go even further than before, which is absolutely fascinating. So astronomy is not just necessarily, don't think our neighborhood, don't think our solar system. We are talking about everything beyond that. We will get into later sort of like the size of the universe. It's really fascinating when you sit and think about just how large our universe is. When we talk about this, even when we talk about our neighborhood, our own solar system's huge. So now when you start to think about in our galaxy and then even bigger than that, we are talking about a really big place that we live in. So how the universe is organized. Now on this picture here, I don't have red text for the bottom. If I were you, I would write it down. So this was an easy, nice image for me to find. We're starting with the small. We will work our way up to the big. So if you want to kind of write it in your notes like Earth, draw an arrow, solar system, arrow, Milky Way galaxy like that, cool. That's what I suggest you do. So we are on planet Earth. Yay, hopefully we all know that. In our solar system. Our solar system has 8 planets, has our sun in the middle. That's its name, just an average star though. Yes, we have dwarf planets, but that's our solar system. Our solar system is part of the Milky Way galaxy, and the Milky Way galaxy is comprised of billions of stars. Billions of stars. So our sun is one of billions of stars in a galaxy. We're going to take a little bit of sidetrack here. When you talk about that, then there's billions of galaxies in our universe. Billions of stars in our galaxy, billions of stars in the universe. Crazy big. Our Milky Way galaxy is organized into another group of galaxies called the Local Group, which is then organized into a supercluster, part of the big universe. One of the patterns that we see in our universe is we see lots of empty space. So you see organized, stuff that's organized, matter that's organized, a lot of empty space. Matter that's organized, a lot of empty space. Gravity loves pulling things in, and that's where we get that sort of organized space there. But if you're talking from small to big, this would be the pathway that you would take going from Earth all the way up into our universe. Just mentioned gravity. Gravity is important. It is one of the 4 universal forces that exist everywhere in the universe. Gravity is really important. It comes up a ton in astronomy class. Not saying it's more important than the other universal forces. It's not, but it just has a lot to do with a lot of the stuff that we talk about in astronomy class. Gravity is a universal force of attraction. So just that first part of that definition there tells us it happens everywhere. It doesn't just happen on Earth. It doesn't just happen on the moon. It doesn't just happen on Mars. It happens everywhere in the universe. There's no reason why it wouldn't. You really got to think that. Why would things be different somewhere else? It is a force of attraction between all objects. That's another really important part of that definition. Attraction. Gravity is attracted. Things want to come together, and it's between all objects. So as silly as it sounds, there is a force of gravity, a gravitational force that even exists between you and the planet Jupiter. It's nowhere near us. We're not near Jupiter, right? But there is that gravitational attraction that exists. We stay here on Earth. Gravity of Earth holds us here because we are closer to Earth. Earth is bigger for us right here. It is also responsible for the shapes of orbits of any celestial body. So whether we're talking about Earth around the sun, or we're talking about our moon around us, other satellites, it's responsible for that. It's also responsible for the shape of those celestial bodies. If they have enough mass, gravity will pull them into a spherical shape, like you see the picture on the left-hand side there. Not everything has a spherical shape. You'll see a lot of asteroids in our solar system that do not. They don't have enough mass. Gravity depends on two factors: mass and distance. Mass and distance. So like I said earlier, the bigger the mass, the more that gravitational pull, but it's also just as important, that distance factor. So distance, if I'm closer, we have less mass than the sun, but the moon revolves around us because it's closer. Now there is an actual formula. There's an actual calculus formula that Sir Isaac Newton came up with. We're not going to get into that. Just keep in mind mass and distance. So the closer two things are, the more that gravitational pull is going to be between them. The more mass an object has, the more gravitational pull it's going to have. That's why we have that stronger weight on planet Earth than we do have on the moon, because the moon has less gravity. Speaking of the moon, so our moon actually does have a name. It is called Luna. It is our only natural satellite to travel around Earth. We believe something bashed into the side of us, hit off the outer part of the Earth. That material coalesced. There was enough of it. It formed a spherical shape. There's the moon. The composition of the moon is very similar to the outer part of Earth. So that lends us really close to that philosophy, and that it was ejected material from the outside of Earth. So the moon, Earth's moon, also called Luna, is actually a natural satellite. So when you hear the word satellite, don't always think it's this thing that's beeping up in space, sending signals around. Natural satellites also exist. Also, the reason why that word Luna is involved a lot of things that have to do with the moon, right? When you guys hear the word lunar, that's cluing you in that it has to do with the moon. Maybe you've heard of lunatic before. We may have also heard the fact that people, they think, get a little bit crazier when there's a full moon outside. Lunatic, and that's actually where that comes from. Our moon is around 250 million miles away. It is not always the same distance away. There's times when it's closer, and there's a time when it's farther away. We had that super moon a week ago. If you watch this video at a later time, it's not going to be a week ago, but supermoon occurs when the moon is closer to planet Earth. So it actually looks a little bit bigger, a little bit more dramatic. Pretty cool. Our moon is about a quarter the diameter of Earth. A quarter the diameter. So take us, divide us 25% diameter of Earth. The moon does not have an atmosphere. So it just, even though it has enough gravity to pull it into that spherical shape, it does not have enough gravity to hang on to gases. There's no atmosphere there. There's no air pressure. There's no anything there. So that's why when you see pictures of the moon landing that happened late 60s, the footprints are still there. No wind. There's no wind. There's no weather there. So you're not going to have any change of any kind there. Also means you can't breathe there. Can't breathe on the moon. There are planets. Yes, I included Pluto. There's the old person in me. Pluto is now technically considered a dwarf planet. We will talk more about those later on, but there's our planets. My very educated mother just served us noodles. My very educated mother just served us noodles. Now, this picture is not the best picture for an astronomy class. I like it. It gets the point across, but it's really not doing it justice in terms of the size of the planets nor the distance from the sun. But we can get the gist of, there's our four inner planets: Mercury, Venus, Earth, and Mars. Our four gas giants: Jupiter, Saturn, Uranus, and Neptune. The sun, our star, much larger than the planets. Big, big, big. Contains 1,000 times more matter than all of the solar system combined. Generates energy in its core from nuclear fusion. So when you guys hear that word fusion, that means things coming together. So elements, hydrogen, fusing together to form helium. In that process of nuclear fusion, a ton of energy is released, and that is what we see in the sun there. The sun is around 4.6 billion years old, we believe. And as we said earlier, life cycle. We have a life cycle that occurs here with stars. It's kind of weird because you're like, the sun's not alive, but it does go through a life cycle. If I just said nuclear fusion is hydrogen fusing into helium, you're not going to have an infinite amount of hydrogen there, right? You're going to have a point at which all of that hydrogen It's going to be fused into helium, and there's none left. So we think it's about halfway through its life cycle. So our solar system that we live in, you'll often hear me talk about it like our neighborhood. It really kind of is. It's our community, is made of the sun, the 8 planets that we just mentioned, and all other objects inside there, including the dwarf planets that I talked about. But we have other stuff too going on in our solar system. We have really cool comets. We have asteroids. So don't just think planets. We have other things going on in our solar system as well. Because these are your first notes that we are taking, you're going to want to take a picture. Make sure it's a clear picture. Make sure it's from up above. Make sure your name is on them. And you're going to submit that on a PDF in Schoology.